Today we're going to be investigating 3 questions. How does groundwater affect the flow of streams and lakes on campus? How constructions that UConn has implemented have changed groundwater movement and stream health? And how is groundwater impacting climate change?
Mirror Lake is a good place to start because UConn describes it as both a landscape feature and a stormwater management facility that receives runoff from multiple campus inlets. So even though it looks like a normal lake, it's also part of UConn's drainage system.
Groundwater is water that soaks into the soil and moves underground through sediment, soil, and rock. Eventually, that groundwater moves back into streams, wetlands, and lakes.
Scientists call this groundwater and surface water interaction. Our research shows that rivers and streams are not separate systems. The two constantly exchange water, heat, chemicals, and nutrients through stream beds and surrounding sediment.
At Mirror Lake and Swan Lake, we look for signs of these connections. Wet soil near perimeters, where water may be going in, tiny flowing channels, or water entering from below can all suggest groundwater or shallow subsurface flow is what is feeding the lake or nearby streams.
This matters because it shows how impactful groundwater feeding is as a source of water for stream and lake flow. If rainfall changes, then the amount of groundwater that is flowing to streams and lakes reacts to that change.
Now we are looking at the developed parts of campus around the lakes. Buildings, roads, sidewalks, and parking lots are surfaces where water cannot easily soak through. When rain falls on these solid surfaces, it becomes runoff. That runoff moves faster on the surface into storm drains, streams, and lakes, just like this storm drain.
On the contrary, when rain falls on soil ground, it can seep into soil and recharge groundwater flow, which goes into Swan and Mirror Lake, then to stream beds. We can see this with the new construction that helps flowing water into a stream off Mirror Lake.
This is important because a peer-reviewed case study of UConn's stormwater infrastructure explains that the university made a long-term effort commitment back in 2015 to manage stormwater using practices that reduce runoff and flooding while improving water quality. This connects to Mirror Lake because UConn's planning documents from 2022 say the lake receives stormwater from campus and that improvements were needed to manage stormwater, slow sediment accumulation, and improve health and water quality. Looking back at the document, they had been planning to build that dam for better aquatic health, and now here it is.
UConn's groundwater has also been found to have an impact on climate change. UConn today used studies to write about the process of groundwater flowing through groundwater seeps and can carry out nitrogen and carbon on its way to flow into streams and lakes. The study conducted on the nearby Farmington River concluded that as much as 20% of dissolved emissions into the atmosphere can be released from groundwater seeps before the water even joins the stream.
Now explaining why this matters. We have learned that water movement also connects to climate health. When storms become heavier, drainage systems, streams, and lakes must handle more water at once. Nature processes of moving runoff and groundwater make UConn implement man-made systems to control it, like the new construction of Mirror Lake. The greenhouse gases released by groundwater processes show how groundwater matters and contributes to climate change. It moves water, nutrients, and sediment, and sometimes gases between the land, streams, and lakes, and it moves it into the atmosphere.
In conclusion, groundwater affects streams and lakes by feeding them from below and contributing to the flow into streams and lakes. Mirror Lake and Swan Lake show the water on campus is not just sitting still. It is moving above ground, underground, through storm drains, through streams, and into lakes. Understanding that movement helps explain the environment environmental health of UConn's campus and the man-made steps that can ensure healthy water systems too.